to
broadcast is on.
All right. Hey folks, good evening, good afternoon, good morning. Thanks for joining in. We still have people who are joining the program, so maybe a couple of minutes before we get started. So we'll let a few more people come in and then we'll get started. Thanks. All right, I think we'll get started. So welcome everyone to today's session, which is Pwning Azure deployments. We would be talking about, my colleague Sharad would be presenting in a short while, talking about Azure secure configurations and misconfigurations. Just to give everyone a little bit of context before we get started. So what we essentially want to show, to you guys today is some of the secure variants that one can look at, and the insecure configurations that people usually do when we are dealing with Azure deployments, specifically with respect to Azure Functions. Now, I know today for many of us who have joined, we are much more familiar with AWS as a service, but increasingly we are seeing many more people taking up Azure, and Azure itself is also gaining a lot more steam in the cloud space today. So we felt it'd be good to talk about some of the work that we have done around Azure, especially on the security space. Just give people some idea that in addition to AWS, Azure is also a viable option when it comes to security. So without further ado, I will pass it over to Sharat, and we shall get started. Sharat, over to you.
Thanks, Bharat. Thanks for the warm introduction. My name is Sharath. I'll be handling the webinar today. The webinar is about handling this Azure deployment securely. A little bit about me. My name is Sharath. I'm a lead solutions engineer from V45. I'm also a co-developer of Orchestron. Orchestron is a platform where you can correlate multiple tool results, technically a security scan results, and you get one single dashboard where you get to see the open vulnerabilities, closed vulnerabilities, whether they are uncategorized, and how to handle false positive and stuff like that. I'm a Python developer by heart, and I also write a lot of AppSec automation. I'm a trainer and speaker at multiple OWASP events, and I also handle private trainings and meetups around the globe. I've also contributed to a few open source projects like DBFast, which is a vulnerable serverless functions deployment framework where you can deploy this particular GitHub repo and then start exploring the vulnerable serverless variants. And I've also worked on few threat modeling projects like Threat Playbook. And I've also automated the burp extension with the robot library, which is RoboBurp 2. I started my journey as a developer, then moved to DevOps, and now I'm into DevSecOps and training. So let's get started with the agenda. In the agenda, we'll be looking at the Azure and its services. And later we'll dive into serverless and whether you want to consider using serverless or not. And if at all, if you're considering using serverless, what are the challenges you're going to face? And what are the security considerations you're supposed to make? We're going to see them in a great detail. At the end, we will be demonstrating an attack on an Azure serverless variant called Azure Functions, where you'll be seeing a lot of interesting stuff. So let's get started with Azure. Azure is nothing but a cloud service variant from Microsoft. Just like you have AWS from Amazon and GCP from Google, Azure is from Microsoft. It provides a wide array of services scaling from infrastructure to serverless, where it gives infrastructure as a service, which comes as a compute machines, and platform as a service where you will have database and notification channels as a service, and software as a service with other logic apps and stuff like that. And serverless is again the Azure Functions variant. So all the user management in the cloud happens through Azure Active Directory. Active Directory, I believe most of you have been aware with the Windows variant where it's called as Windows Active Directory. Azure Active Directory is kind of very similar to that, but not exactly. There are a lot of differences between a Windows AD and an Azure AD, but the concept is same, which is the user management. Azure is really good at handling both private cloud and public cloud, which is the hybrid cloud. So let's get started with serverless. So as the name suggests, serverless means there are no servers. Is that true? Not really, right? Serverless doesn't mean that there are no servers or anything. Serverless are nothing but the functions deployed as an ephemeral container or a VM. If you're trying to deploy a serverless function through AWS or Google Cloud or Azure, them will be or a VMs. VMs are usually by AWS and other services are containers. Serverless provides an event trigger architecture where if a particular event happens, then trigger a serverless function kind of a thing happens with the serverless module itself. Every serverless function runs for maximum 15 minutes. If at all, if your workflow needs more than 15 minutes or something like that, then serverless is not for you. If your workflow ends up with less than 15 minutes, then you can go ahead and try the serverless. For a scenario like where you have the workflow running for more than 15 minutes, you can use the serverless function as a trigger. And then once the trigger is set and another service is running, then the serverless compute will shut down since it's an ephemeral container. Some of the runtimes supported by serverless are Python, Go, Node, .NET, and Java. And if at all, if you have other runtimes requirements like PHP or Rust, then some serverless providers provide you option with custom runtimes also. So how did we end up with serverless? Usually we used to deploy our services with one single box, where we always had one single box where we have all the services like database, my app, my web server, and also my notification channels or queue channels, everything in one single box. And it used to run with 8 GB of RAM or 16 GB of RAM kind of a thing. So then we got to know that, hey, this is not a scalable architecture. So if I have to scale, I have to deploy another 8 GB box or a 16 GB box, which is not scaling. And we also got to know that all services doesn't need scaling. So then we ended up with the microservices framework. So with microservices, we ended up using Docker containers and other container runtimes. But we also got to know that this containers or whatever the microservices we are trying to use need not have to run all the time. They can be ephemeral also, just like one API call. If you send a request to a server, once the response is gotten back to you, then it can be a ephemeral state or a function. That's where we ended up with the serverless, which is the serverless function. So why you should use serverless? As I said, serverless is pay per user. So usually with the server deployments, what happens is whether you're using a server or not using a server, you're still paying for it. For example, let's take a scenario where in an odd time or in some other time zone, if your server is not receiving any request or it's not functioning at all, then in that case, in servers, you still have to pay something because you're already owning the infrastructure from the cloud provider. But in serverless, it's not the case. If some compute is running for you for that particular moment, only for that you have to pay for the compute. That's about pay for usage. And you need not have to maintain the servers. Since this thing serverless is an ephemeral state, you need not have to maintain the services or the servers. So it's also a microservices friendly architecture where you trigger a particular request and then it can contact other services within the cloud, and then it becomes a microservices friendly architecture. Suppose if you have 15,000 requests or 30,000 requests coming at one shot, usually servers with a monolithic style of a deployment will not be able to handle it. To handle that kind of request, you have to do some kind of an horizontal scaling by deploying multiple machines. But in serverless, that's not the case. So if it takes 30,000 requests, it will trigger 30,000 Lambda functions or 30,000 Azure functions where it can scale by itself. That's why it's called as auto-scalable. In serverless, you are focusing more on code or features, but not on the servers. So some of the providers of serverless, taking in the clockwise direction, one on the 12 o'clock is the AWS variant called Lambda, one at the 2 o'clock is the Azure variant called Functions, one at the 4 o'clock is Twilio Functions, one at the 6 o'clock is the open source variant called OpenFast, one at the 8 o'clock is the IBM Functions, one at the 10 o'clock is the Google variant called Google Cloud Run or Google Cloud Functions. So who's using servers? V45. V45 is our company. We extensively use serverless for a lot of our internal apps and services. And other companies like Netflix, Coca-Cola, iRobo, Thomson Reuters, Guardian, T-Mobile, and CodePen, all of them use serverless for different use case scenarios. Let's see one case study from Coca-Cola. So here in this Coca-Cola case study, Coca-Cola used to use the serverless variant for verifying whether the particular vending machine is running low on a beverage or not. Till 2016, what they used to do is to handle this kind of workflow, they used to use 6 medium-sized machines, which used to cost them about $12,864 per year. Once they started using serverless, the cost brought down to $4,490 per year, which by taking 30 million requests. That's a huge request with a huge saving. That's where you have to consider the serverless for your functionalities or the workflows. Let's see the Azure variant or the Microsoft variant of serverless. Azure Functions is nothing but a serverless framework from the Microsoft. It can be triggered via wide range of Azure services. For example, let's take a scenario. You first contact Azure function and then talk to another services, or take the other way where you talk to the services first and then trigger a Azure function. Both the ways can be handled with the Azure Functions, where you first talk to the Azure Function, then talk to other cloud services, or talk to the other cloud services, and then directly trigger an Azure Function. Both the ways can be handled. That's why it's called an event-based framework, where it can talk to other services as well. So this is one simple example where a user uploads a photo which gets hit to the serverless function called Azure Functions, and then it gets stored in a Azure service called blob storage. And this is another e-commerce scenario where a particular user is trying to order something. The order is registered via Cosmos DB, which first hits the Azure Functions, then goes to the Cosmos DB. Once the Cosmos DB registers all the events, then it triggers other Azure Functions to handle the tags and payments and other stuff like that. So let's try and deploy our first Azure Functions deployment. So to deploy this, I am using a framework called Serverless, which stands for SLS. It's going to take a while. In the meanwhile, let me explain the code. So here's my code. I'm trying to run a particular e-commerce kind of a requirement where I'm trying to handle a YAML file where this is a expense management kind of an app, where if somebody goes for a particular event or something, or an employee goes for a particular event, they will have some kind of an expenses to claim from the company. So what they will do is they will send the request in a YAML file, something like this, where I am trying to attend a particular Starbucks conference, or sorry, DevCon conference, and who is the merchant? Here is the Starbucks. So once they upload the YAML file, it will process the reason and tell me why this particular bill is uploaded. That is the kind of a scenario here. So to deploy this function, I am maintaining a particular configuration with serverless YAML file here. So I'm trying to deploy this to a region called West Europe, and I'm using a runtime called Python 3.6. And I'm also setting some dummy environment variables called foo. And I'm handling the request via post method. So it's taking a while to deploy. Once it is deployed, you'll get to see here. So let's see whether it is deployed or not. So it is taking a while to deploy. Once it is deployed, you get to see from here. So what it does is, it essentially creates a resource group in Azure and then creates a storage account where it will zip the code file and put it into the storage and then start running from there. So the function code runs with the Azure function. The code will be accessed from the storage container from the Azure services. So it has created an artifact with a zip file, and it will be uploading to a storage container here. So it has created a storage account here, where if you look at the containers here, it would have created few containers for uploading the zip file. Once it is uploaded, then you can look at the functions. I believe it should be deployed by now. Yeah, it is deployed here. And my functions is a hello app, which will be handling the YAML upload functionality. So yeah, it has finished uploading the blob. And then once we have this deployment finished, we will try and upload a YAML file to know whether correctly or not. So it's taking a while. Let's give a few more minutes. Let's wait for a few more seconds. It should be done since we are on the sharing mode also, so it will be a little lag here. That's okay. So yeah, here is the code. Here is the deployment spec, and this is the YAML file which I will be uploading for the serverless function. It is taking a while. Sorry about that. Once it is uploaded, it will give me a URL where I can post my YAML file to the Azure service. So here I am just handling one particular event only. I'm not talking to any other services. This is the URL where I can upload my YAML file. So I'll be using the post method, and I'm using a Perl variant called HTTP, where I am uploading a file called build.yaml. I think it's a form upload, so I have to use -f as the parameter here. So once it is uploaded, it will come back with a response saying that, hey, why are you uploading this particular file? Yes, I am attending a DEF CON conference. That's the reason I'm uploading this particular file here. That's about the deployment. And if you see here, it should have deployed the function here. So this is my function. And if at all, if you want to see what all things are there, it also logs, I guess. So, but logs are usually slow in Azure. It might take a while to fetch the logs, but that's okay. In the meanwhile, we'll continue with the other stuff. So as always, with great power comes great responsibility. And that great responsibility is nothing but the security. And if I talk to people who handle the security in the company, they say that security is always security. So if you look at the serverless security, the functions, whatever the functions you're trying to write, they are still the code. So since they are still a code, there might be a place where you will have some vulnerable code going into the serverless function. And since this serverless variants are ephemeral in nature, there are no frameworks built as such to handle this kind of a micro-style deployment. And functions are connected to other services through events, which increases the attack surfaces. And as I've already shown that serverless.yaml file, they still need some kind of a configuration where if a user or a developer tries to do some kind of a misconfiguration, then they will be vulnerable to other security risks as well. So in some cases, to contact to the other services within the cloud, you might have to give some kind of a higher privileges to contact to the services. So then most of the cases, what the developers or whoever is trying to configure, they'll try and provide the extensive privileges like star or all or something like that, where instead of handling one particular service with one particular kind of an objective, they will get more privileges, which will be exposed to other security risks as well. And whatever the environment variables we are trying to put into our serverless function, they're all stored in a plain text. So most of the cloud providers store the secrets in a plain text itself. They are not some kind of encrypted or encoded. They are just plain text. Some of the misconfigured roles, as I said, when a developer or whoever is deploying, they will have some kind of a roles which will give a wide spectrum of attacks surface for the attackers. So once a particular service is compromised, they will be able to gain the access to other services also, because there are various roles which are connecting to other services. That's the reason where your pay-per-usage model will also turns to be an expensive one. Let's try and attack the same serverless function which I tried to deploy. Instead of sending an actual file, what I'm trying to do is I'm sending a malicious file now. So if you look at the malicious file, instead of sending a write reason as a string, I'm sending a Python code where I want to know what are all the environment variables in this particular Azure function. So what I will do is, instead of sending the write function, I will send the malicious file. Sorry about that. I will send the malicious file. So if you look at this particular malicious file, since it got exploited, it gave me the environment variables in the Azure functions. So let's see what all environment variables are put inside the Azure functions. There are quite a few. Let's see what are there. So I'll put that in a new file here, and let's make it a little better looking. So that we'll have all the environment variables clearly visible to all of us. If you look at here, there are about 80 environment variables in one single function. Honestly, don't know why this particular function, which is handling only one request, had to go with 80 environment variables. And if you look at here, so as the first thing, you'll get to know that why this function has so many environment variables. And once I went through some kind of a research, I looked for certain sensitive keywords called key, where I got to know there are a bunch of environment variables here which are sensitive here. So when I did research on this particular thing, I got to know this is a storage connection string. What I did is, after some research, I found one exploit file which was there in Azure article itself. So what I tried to do is, I took the code from that particular article and replaced the connection string which I got from my YAML file. So if you look at the containers here, so let me show the containers before I exploit. So in this storage account, you see there are only 4 containers here. So what I will do is, I will try and run this particular exploited storage connection string, and then try and upload some kind of a malicious file to the storage account. So if you see here, there are 4. Now it will be 5. So once the attacker, whoever gets access to this particular connection string, they will be able to create another container and then upload some malicious or some rogue files into your Azure storage account. So for whoever is trying to attack, you are trying to pay for their resources on your cloud. So this becomes expensive because your pay-per-usage model has gone expensive, because your Azure function is vulnerable to some kind of attacks like this. And Azure by default has stuffed some sensitive information into your Azure functions itself. And I also got to know Azure function runs some containers. I also looked for some container images. And when I try and download this, when I try and download this, it will download that also. So which was open for everybody to access this particular container. So if you see here, this particular container, which is open for everybody, and what I tried to do was, I tried to run this particular container and see to see why exactly this particular container is like this and what exactly it contains. And then when I got inside the container, I wanted to know what was the operating system it was trying to use. So I tried to do cat OS release. I got to know it was a Debian container. What I tried to do is, I wanted to know what all vulnerabilities are there in this particular function. So what I tried to do was, try to run a clear scanner on this particular container. So here I'm trying to run a clear scanner, which is a container analysis, vulnerability analysis scanner, where when I tried to run, it gave me a bunch of misconfigured libraries, or libraries which are already vulnerable to some kind of attacks. We're going to see in a few seconds. It should be available in a pretty soon. So again, moving on to other sensitive environment variables, I got to know, since zip file is uploaded to Azure services, I was curious whether that zip file is there, some is exposed to some environment or not. I got to know this particular string contains some kind of a zip variable, and I try and access from the browser, and I was able to download something on my machine. So I created a folder here and then downloaded it directly onto my machine, which was about 20 MB file. So once that was done, I tried to extract the zip file. Unfortunately, the zip was not a normal zip format. It was some kind of a 7-zip format. Let me show that to you. If I try and export this particular zip file, I was not able to export that. What I tried to do was, I used the 7-zip variant of the zip extractor to see what that particular zip file contains. So after extracting, I got to know there are few things which was my code itself. So if you look at here, this was the code I tried to upload for my Azure function, which is directly in the attacker's hand now. So which was that because of the environment variable stuffed inside the Azure functions like this. I believe the container scan is complete. I guess it's still taking a while. That's okay. And if you look at the other environment variables, so if you look at here, there is something called container encryption key. I haven't explored this particular key, but I'm sure this is some kind of other sensitive information as well. And there are other keys like Azure Web Encryption key, container encryption key, some storage key. There are a lot of environment variable stuff which are all sensitive in some kind of a nature here. So I think my scan is complete. If you look at here, there are a bunch of vulnerabilities thrown in this particular container. So if you look at here, this particular CVE, it says that this is vulnerable to some attack, which was found recently in this year itself. And then this is on a particular Linux box itself. And it also used some vulnerable libraries like glibc and libidian, and it also used Python 2.7, which is deprecated in January 2020. All of this sensitive stuff are all stuffed inside this particular container itself. So this is about the attack. So let's look at the defense now. So defense is about whenever you're trying to deploy some kind of Azure functions or any serverless function, always run the static analysis code or static analysis scanner on your code. And sometimes you also end up using some kind of a vulnerable libraries. So always do some kind of a source composition analysis scan before deploying on the cloud services. So if you miss this kind of secure best practices, then you will end up having this kind of sensitive information exposed to an attacker where they will be compromising other services in the cloud itself. Since event-based architecture is very new, I suggest you do threat modeling on the event-based architecture as well. And as and when every request thrown to the Azure functions, please log them. So if you log them, then you will have some kind of a visibility to know whether the attack is happening on a cloud or not. So if you're trying to provide access to other services, I suggest you give limited privileges for each function. So that's about my session. So I'm open for any question and answers.
Thanks, Sharad, for a very informative session. I think we have a couple of questions already, but I'll start with the first question from Surendra. How can we log every request if that can be shown?
So if you look at here, in the container, I have shown you there is some kind of a log happening here. So in the functions, you saw the logs happening here. You can pull that into any functions you want, or Azure also has some kind of a log management system where you can put the logs into one single location. I think here it should show the logs. Okay, it got cleared. Let me try once again with the deployment. It's usually a little slow to put down the logs here. And there is also log analytic workspace where you can create a workspace and log every action from there. So here you see the logs are all executed here. You can put all them into one particular workspace. Any other questions?
Right, thanks, Sharad. So we have one more question. While AWS has tools like Lambda Guard, what tools would you recommend for Azure Functions for offensive testing?
Okay, so AWS, that Lambda Guard is an open source variant for AWS Lambda, but for Azure, I don't see any this kind of open source tools. But there are some commercial tools from PureSec and Protego where they will be running extensive scans on your Azure functions to know whether they are vulnerable or not.
All right. One more question. Are Azure Functions exposed directly, or is it via an API gateway, or similar to AWS Lambda?
Azure Functions can be exposed in both ways. One through API gateway, that is usually there, and the other through events where you trigger. Some other service will trigger an event where there is no API gateway or something like that. So, and that is also some kind of vulnerability where events are talking to other events without any authentication and authorization stuff. So that's also there. Yeah.
All right. So since Azure Functions are containers, does it affect the overall performance if you compare it to a micro VM?
Yeah, I would say so. Usually with micro VMs, what happens is there will be some kind of a cold start kind of a thing happening. Usually if you trigger AWS Lambda, it will take about 2 to 3 seconds to spin up the micro VM. But in Azure contents, Azure containers or Azure functions, that's not the case. Usually what happens is once you trigger a request, the container spawns up just like that, and you will be able to access some kind of a resource within the cloud.
There's another question. So is it possible to run a SaaS scan on a container? Assuming no, should we run SaaS scans post-build before packaging?
I suggest not to do by the post build. Usually you should do before the build itself. So once you start building your package into some kind of containers or jar files or something like that, I suggest you run the scan before you deploy or before you go to the deployment stage itself. Or if you want to run the SaaS scanners as a container, I think you can do that because there are a lot of containers already there. For example, FindSecBugs is one such thing where it is already containerized for people to use, which the FindSecBugs is usually for Java deployments.
All right. I think we have one more. What are the best Azure managed cloud services that can help in implementing defense in depth for the application stack?
Yeah, so if you look at here, the storage, what we tried to compromise, it was accessible to the outside world just like that. If you have some kind of a firewall set up within the cloud itself, then you would have blocked the attack itself there. So Azure by default has some kind of a firewall mechanism. You can leverage that. And to store some sensitive variables like this environment variables, whatever you're trying to put in, you can use Key Vault for that particular services. And there are other services also, but I am not exposed to those services. But currently I can see of Key Vault and the firewall as some kind of a defense in depth for your attack prevention.
All right, I think there's one last question. Can Azure Functions be triggered via events? If so, what kind of events can trigger these functions?
So yes, Azure Functions can be triggered via events. For example, as I've shown you in that Cosmos DB example, where if a particular record is returned to Azure Functions, then or a Cosmos DB, then the Cosmos DB will trigger a event to Azure Functions. So that event can be triggered from Azure services as well. Yeah.
All right. There was a question with respect to the recording. The recording of this webinar would be posted on our YouTube channel. And you can go into V45's YouTube channel to, look at the webinar again and, of course, share it with others. So I think that's all the questions that we had. Yeah. So, thank you folks for joining. Just wanted to remind everyone that, secrets training is something that we do. I mean, Azure training and AWS and cloud training is something that we do quite often. And, please do, visit our website, v45.com. We have some specific courses on, Azure secrets and AWS secrets. And I think we are planning to run a public training program sometime in October. So, do check it out. If you have any questions, I think you can, do reach out to us, over our, LinkedIn and Twitter channels, or you can reach out to our, general email ID at info@v45.com, and we'll definitely get back to you. Thank you. It was a pleasure having you, and, have a great day and have a great weekend ahead. Thank you. Bye-bye.